In this section, we are going to talk about the multi-spanning tree MST protocol. Let's say that we have a topology which consists of three switches like this. Normally, switch 1, switch 2, or switch 3 may become a root bridge in a three-switch topology like this. And according to these three different scenarios, the ports of the switch will have different port roles. If we were to have 100 different VLANs, for example, it would be unnecessary to calculate this individually for each VLAN, since the result will always be the same and the control plane will have an unnecessary heavy load. It would be unnecessary to calculate this. With the multi-spanning tree protocol, we are removing this handicap from and we are reaching a more effective structure on the network. One of the biggest advantages of MST is VLAN load balancing, and let's consider our topology. And our topology consists of two links and 1000 VLANs as shown. While we are making 1000 spanning tree calculations in classical spanning tree protocol for a topology like this, but in MST, 1000 VLANs are mapped to 2 MST instances just, and you get rid of unnecessary calculations. For example, you have instance 1 and instance 2 for this range, and you choose different root bridges for this range, and you just apply it to the bridge. This architecture provides multiple routing paths for data traffic and enables load balancing as well. MST converges the network much faster than older versions like RSTP, PVST, or STP. And let's talk about the MST region concept now. The MST region is the switch group that comprises the following parameters. The first parameter is the instance name. The second parameter is the revision number, and the third parameter is the VLAN to STP instance maps. Please keep in mind that details are not shared between different MST regions, and different regions see each other as virtual bridges. One of these regions is used for inter-region communication, and that's called regional root bridge. MST supports multiple instances, and instance 0 is used to move all internal information about the STP. Let's take a look to our topology. For VLAN 10 and 30 and for VLAN 20 to 40, traffic flows through different paths. For example, for VLANs to 10 to 30, this bridge is the root bridge, and for instance 2, which is mapped to VLANs 20 and 40, this bridge may be the root bridge. The MST revision number provides a way to track change to the MST region. The revision number is not automatically incremented each time you make the change to the MST configuration. That's a really important part to pay attention. Each time you make the change, you need to increment the revision number one by one. And we have MST Extended System ID concept, which consists of 12 bits and carries the MST instance number. And here is the most important part of this section. We have 4 different switches, as you can see that in our topology. we have distribution 1, distribution 2, access 1, and access 2 switches. To configure MST for all these switches, the first thing we should do is converting the spanning tree mode to MST by typing spanning tree mode MST configuration in all these switches. The second thing we need to do is providing the name, revision number, and VLAN to STP instances. As you can see that we defined ABC as the name, revision number 3, and VLAN to instance mappings on all these switches. Please pay attention that because of these values are the same, name, revision, and VLAN to instance mappings are the same, these switches, all of these switches belong to the same region. Okay. But please pay attention that we just have some different configuration for distribution 1 and distribution 2. For distribution 2, we have spanning tree MST2 priority 8000 and blah blah, and we have spanning tree MST2 priority 4000 and blah blah for the distribution 2, which means this guy will be selected as the root for instance 2, which covers the VLANs between 100 and 199. On the other hand, we have configured spanning tree MST 01 priority to 4000 and blah blah for this, and we have configured 8000 or something for the distribution 2. And this configuration means for the instance 0 and for the instance 1, which covers the VLANs between 1 and 99, this guy will be the root bridge. And let's take a look to the MST root bridge and path cost configuration right now. To change the root bridge, we can use the spanning tree MST1 root primary, and if we want to define a secondary root, we need to use the spanning tree MST and instance number and root secondary. And if we want to change the cost on a port, we need to use spanning tree MST instance number and cost and the cost value. And to verify the MST configuration, we can use the show spanning tree MST and instance number. For example, for MST1, VLANs mapped are 2 and 3 for this example.